All right, so guys, notice the title of this note. It's lesson 2.2 and what? 2.4, all right? And it's about conditionals and biconditionals. So these are talking about, we're really going to be going back to working more in the deductive reasoning, right? Reasoning based off of rules and facts. But we're really going to learn about how to take a conditional statement and change it to maybe a true statement or not a true statement, but how to identify things and really the way of thinking we do. Because let me give you just a basic example. You all do this. For instance, when you get out of bed in the morning, you look out your window. If it's sunny, you wear different clothes than if it was snowing, correct? That's a conditional. So if it is sunny outside, I wear shorts to school. If it's snowing outside, I'm wearing earmuffs. You know, that type of scenario. It's really a logical way of thinking. This is how you think all the time. If this happens, then I get to do this. Your mother pulls this on you all the time. She says, if you clean your room, sweetheart, then you can go to the movies with your friends. You know, stuff like that. Your moms are mean. But that's what we do to you. We use conditional reasoning. So with this first one, what is a conditional statement? So first things first, it is an if-then statement. So really it's just an if-then statement. So a quick example, if today is Friday, then tomorrow is Saturday. Now, here's another thing. You can actually decide if this is a true or a valid statement. So you can find truth behind this. Is that a true statement at this very moment? No, because what's today? Monday. Tomorrow's going to be what? So therefore, I know it couldn't have been true. So it's an if-then statement. Now, the if and the then are like signals, okay? They tell you a couple different things. We divide the sentence up into two things. We have what's called the hypothesis. And when we have the hypothesis, it is the if phrase. Now, here's the funny thing. It doesn't always have to be very obviously written as an if, but it's always going to be the if phrase of the statement. So when you're looking at that sentence up above, today is Friday, notice when I say the hypothesis, did I use the word if in it? No, if is just the signal, that's what it is. So on this one, today is Friday. That's going to be your hypothesis phrase with that. Then with it, we also have to have a conclusion. Well, the conclusion is the then phrase. So, I mean, this is real technical, isn't it? It is the then phrase. So in this case, again, don't use the word then in it, just tomorrow is Saturday. Tomorrow is Saturday. Now, we actually use a lot of symbolic representation. This unit, we're going to use a lot of letters, not variables really, but there's still letters to represent something, to represent phrases, because sometimes it just gets really confusing to have so many words. So in here, we're going to actually use a couple different symbols. So first things first, if you ever see an arrow between two letters like that, that means that's a conditional statement, and you actually read it like this. If P, then Q. Woo, right? Wow. If P, then Q. So if you ever see an arrow, some of you have used this without even meaning to. How many of you have ever worked across the page and go, all right, 1 + 1 = 2, then 2 + 3 = 5, right? Have you ever done that? Aren't you kind of doing that? Now, it drives me nuts because I want you to go down the page, but really, when you've ever done that, you're just telling the person, I've done this, please then go to this one, right? So you've kind of naturally done it. Now, we use letters to represent these. A lot of times the hypothesis, we use a P, capital P or lowercase p. You can use any letter, to be honest with you. And in conclusion, a lot of times we're going to let Q, a lowercase q or a capital Q, represent the conclusion of a statement. So that's why when you ever hear me say, if P, then Q, you know P represents the hypothesis, Q represents the conclusion. And we also want to make sure if everything is valid or not. So this is a little bit of fun. I know a couple of you have actually had some logic classes, so this is a lot of fun. So when we do this, we have what's called truth tables, okay? They take all combinations of false statements and true statements and see what you actually get, all right? So when you have a truth table, you're going to have your two what are called propositions. So you have your P and your Q, and then we always sit there in the last column and go, okay, what's true or false? I want to know what operation I'm doing, and I'm actually doing a conditional statement. Now, here's all possible combinations. So if you go true, true, false, false, go true, false on the last column. And let's have a little bit of fun with this, because this is where people get totally confused in this class, and it's wait, don't do this to yourself. But here's a logical thing. All right, if I have a conditional statement and both of them are true, so if I have a true statement, then I have a true conclusion, you're going to assume that my conditional statement is going to be what? True. Like, it's very simple. It's true. Right? So a lot of you like, if true, then true. That makes sense. I have a true statement. Awesome. What if I have a true hypothesis but a false conclusion? What do you guys think? It's false. Josh thinks it's false. What do you guys think? False. Yeah, all right. Think false. Okay. I'm going to agree with you so far. But what if I have a false hypothesis but a true conclusion? I'm not going to let you answer this one. What do you guys think? What if I did something like, if 1 plus 1 equals 3, then 1 plus 2 equals 3? What do you think? Think it's false? It's actually true. Because what was your conclusion? True. All right, and this one, people love this one. If false, then false. What do you guys think? False? He thinks it's false. What do you guys think? True. Someone's like, 2 negatives make a right? Well, not quite, but it is actually a true statement. Did I just blow your minds? Okay. It's like Gregor said, this doesn't make sense. False and false. Two wrongs don't make a right, correct? That's kind of what you're thinking. All right. Let me kind of give you a fun little example here. All right. Oh, my battery is running low. I got to save it real quick. With this, okay, I'm just curious. Are any of you guys willing to be an example, one of the guys in this room? All right. Connor, do you have a girlfriend? Okay, you do now. All right. So Connor has a girlfriend. Her name's Sue. All right, Connor, are you good with it? Her name's Sue. Okay, she's really cute. She's really nice. You're in love, okay? So Connor's with an O or an E? Oh, okay. All right, so we're going to use Connor as an example, but here's the part I want you guys to do. Highlight this, label it, whatever. We're going to show what type of boyfriend Connor is in this, and he's going to help us prove that this is true every single time. All right? So the only time he's ever going to be a bad boyfriend is if he is a true hypothesis, but a false conclusion. All right? So, Connor, here's the statement. You are in love, okay? So you tell your girlfriend, you said, hey, you know, I'm kind of a broke young guy here, but if I mow the lawn and I earn $30, I'm going to take you to the movies. All right? Doesn't he sound like a nice guy? He's going to earn money to take his girlfriend out, right? So now let's go through these examples. So first example, true, true. Connor mows the lawn, earns the $30, and then he takes her to the movies. Is he a good, honest man? Right? Now, what happens if Connor mows the lawn, earns the $30, but does not take Susie to the movie? Girls, what did you all just want to do at that moment? Break up with him, right? Yes, because he's a liar, right? Because he lied to her. He said, hey, I earned my $30, but I'm sorry, sweetie, dearest, I'm not taking you to the movies now. And he would be single, right? Because he lied. But notice he had the true hypothesis, but he didn't follow through on his word. So basically, you're not a man of your word right now. Okay, let's see if he can redeem himself. All right, let's see if he can redeem himself. What if Connor does not mow the lawn, but he still takes Susie to the movies? Is he a good guy? Did he still make his girlfriend happy? Right? If he didn't mow the lawn, but he still took her to the movies, is he a good guy? You're a good boyfriend right there, Connor. See? Way to go. He's doing great. So that third line makes sense. Now, how about the last line, though? What if he doesn't mow the lawn and he doesn't take her to the movies? Did he end up lying to her? No. He's still a good, honest man. It's still a true statement there. Yes?
I understand that, but what do you use the today is Friday, tomorrow is Saturday?
Well,
I think it makes
Well, it doesn't make as much sense as when it originally went, but so if today is Friday, all right, so we'd sit there and say what? False, and then what? So is it a true statement in the sense that it's neither one, right? Isn't that just mean? Now, what happens though if I am on Friday? Is it still what? True, right? So if it's on Friday, it's true, true. Yeah, so this is still, now, it's false in our minds, but this was still a true statement. Because it's false, then false, so my validity is what? True. Isn't that mean? All right, some of you are like, oh, all right, here's what I need for you to do. Some of you are not going to like this. Some of you are going to have to do something you hate doing. You're going to have to memorize this. Did you all hear me? You have to memorize this. You have to memorize the only time that Connor's ever mean to his girlfriend, okay? The rest of the time, notice he never broke his word. Use that as a way to memorize the rule. For some of you, logical reasoning unit is going to be really tough. That sounds really mean, but trust me on this. You'll get it down. So Connor, right now, memorize it. You'll do it, all right? We're going to do some more examples too, don't worry. All right, so how about this next one for me, guys? Here's an original conditional statement, all right? It says, if an angle's measure is between 90 and 180 degrees, then it's an obtuse angle. Is that a true statement? Right? Yeah, so it'd be true, true. So it's a true statement. So this original conditional is a true statement. All right, guys, what's your hypothesis? What's the hypothesis on this one? What do we got? Hypothesis, Hallie. All right, now I'm going to take you back on that one. Remember, I don't need the word if, though, right? All right, it's just everything following it, but you're totally right. If the angle's measure is between 90, 180 degrees, so that's going to be the hypothesis. Great. Guys, what's going to be my conclusion? What's the conclusion on this one?
It is an obtuse.
Yeah, it is an obtuse angle. So remember, that's going to be your hypothesis. So here's my hypothesis, and I'm going to let that be P, and then I'm going to have my conclusion, and that's going to be Q. Now, life would be pretty boring if you could only ever do it one way, right? We have other ways of writing these, and so there are other conditional statements based off of them. Now, understand something. Can we prove stuff wrong? Can we use counterexamples? Basically, that's where it's awesome. We can prove stuff wrong because of counterexamples. That's how we prove conditional statements wrong. But we can make new statements as a result. So one of the things that we do is we write the converse of a conditional statement. So first things first with this one. Now put the arrow in there. Now looking at that symbolically, what did I do with my P and my Q? I switched them. Now here's what I want you everyone to hear me. I did not switch the words if and then. If and then, stay put. They're good. It's the phrases after that switched. So what is a converse statement? It's exactly what you just told me. They're switched. It's a conditional statement formed by switching a conditional statement oops, I should abbreviate better grammar than that. Statements, hypothesis, and conclusion. Now, this will throw people off. Again, what doesn't move? If and then. It's the statements afterwards. And you have to also be grammatically correct with this. So when you're doing this one, I'm going to start with the word if still. My conditional statements are going to start with if. But it says I switched them. So what should come next? It's an obtuse angle, right? But can I start with that pronoun? Can I start with a pronoun like that? We're going to sit there and say, if an angle is an obtuse angle, then what? Exactly. Yeah, it's as simple as that. Don't overly complicate it. Then its measure is between 90 and 180 degrees. Notice the flip-flop, but also notice what did not move. Guys, this is the number one error people make. They move the if and then when they shouldn't. Remember, if and then are just the signal of a sentence's hypothesis and its conclusion. Don't move them. Are you guys with me on that? Because if you move them, you're just saying the same thing you originally had. So be really careful. Now, isn't that pretty easy to do? Right? Isn't that pretty easy to do? Let's try another one. All right, inverse. Now, inverse means opposite operation, right? All right, there's a symbol you need to know in order to understand this. So right here, you guys draw the squiggly for me real quick, all right? That means make opposite. Okay, that's a negation symbol. So I'm going to make opposite whatever the value is. Basically, here's the word I want you to remember, not. Okay? You're either going to put the word not in or you're going to take the word not out. So we're going to make it out there. So anytime you see that, the similarity symbol is really what it is, or the tilde symbol like you were in Spanish, it means to negate, okay? It means to make opposite. So for an inverse statement, notice I'm still going to have a conditional statement. Notice the arrow is still going there. So it's still an if-then statement. But what did I do to the hypothesis and what did I do to the conclusion? What do those two symbols mean? What did we just define them? They mean what? Opposite. So we're going to sit there, and when I read that, that says if not P, then not Q. So you're going to use the terminology there. So really what it is, well, it's a conditional statement formed by negating both the hypothesis and conclusion of a conditional statement. So we're going to go back to the original one that we did earlier and how we defined P and Q. All right, so if I'm doing this case, I'm not switching their spots. I have to negate them. So read that first original conditional again. It says, if an angle's measure is between 90 and 180 degrees, how do I make that opposite? What would I say? If an angle's measure is what? Yeah, if an angle's measure is not between 90 and 180 degrees, then what? What would we say next? So if an angle's measure is not between 90 and 180 degrees, then it is not. I know, it's real simple, isn't it? It's just the word not in there. Then it is not an obtuse angle. Awesomeness on that one. So if an angle's measure is not between 90 and 180 degrees, then it's not an obtuse angle. By the way, is that still true? Yeah, because if it's not between those two, right, then it can't be obtuse. Yes, ma'am.
But what if you have like 100?
Yeah, is it between 100 and, is that between 90 and 180? So it says if it's not between those two, then it's not an obtuse angle. If it's 190 degrees, we don't call it an obtuse angle anymore. All right, contrapositive, okay? A contrapositive sounds like you're contradicting yourself, isn't it? You kind of are. A contrapositive is the marriage of the converse and the inverse, okay? It's the combination of them two together. Notice it still gives you another conditional statement. But notice what I've written there symbolically. It's if not Q, then not P. So what has this done? It's a conditional statement formed by negating both the hypothesis and conclusion of a conditional statement then switching them. Do you see how you have to do both? Does it really matter if you switch them, then negate, or negate, then switch? Think about that. Does it really matter which direction you go? No, but you need to be able to do both. Again, let me emphasize this. What does not move? The if and then do not move. Notice they did not move on the inverse. They did not move on the converse. But we just need to make sure that we write it well. So guys, help me. What's going to be after the if here? If what?
If it's not.
All right. If it, are we going to use the word it?
No.
All right. We're going to say if an angle is not an obtuse angle. There should be a T there. Obtuse angle. Then its measure is not between 90 and 180 degrees. Notice again, did anything move on this one? Did my if and the then change spots? What changes are the phrases afterwards, not if and then. Leave them alone. I don't know how many times I'm grading a quiz and I have to count it wrong. Even though the kid thought they were switching things, because they switched the if and then with it. Never move the if and then. Are we all on the same page on this? Because you change its meaning. Now, is that really that hard to do, guys? Is that hard to rewrite sentences? No, not really. Now, there is a time when we work with biconditionals here, okay? So when we work with biconditionals is another word. Bi means to what? To conditionals, all right? It is literally means it goes both ways. So here's what it means. Look. What this does, it allows you to write it either direction. Allows you to write it either direction. So if I have a biconditional, it actually changes the phrase. It's an if and only if statement formed if a conditional statement and its converse are both true. Now, I'm going to tell you something right now. You can write biconditional statements that are not true. But that meant you didn't start with true statements to start with, right? So you're going to see biconditionals written by people around the world that just don't matter because they're not done both directions. So you want to make sure that your original statement and your converse statements are both true. Otherwise, I don't want you wasting your time writing something that's just flat out wrong, okay? So that's the reason why I asked you to make sure they're both true. Now, guys, look at this original up here. Was the original statement, if an angle's measure is between 90 and 180 degrees, then it is an obtuse angle. Is that true? Yes. Is this converse statement, if an angle is an obtuse angle, then its measure is between 90 and 180 degrees. Is that true? Can I write a biconditional? The answer would be yes. Well, how would you write it? Well, it doesn't really matter which one goes first. In fact, I think it's actually better if your conclusion came first this time. So you could sit there and say something like this. An angle is an obtuse angle. And what phrase do I use instead? If and only if. If and only if its measure is between 90 and 180 degrees. Actually, we should just write it out the way it was originally. Here we go. Keep it pretty simple. Now, could I have written that conditional statement differently? Could I say an angle's measure is between, how do I want to say this right? An angle's measure is between 90 and 180 degrees if and only if it is an obtuse angle. Do you notice how you could flip it around and it's still true? Notice, do I have an if or then in this one in the sense like in the front and in the middle? No. The phrase that you have to use in the middle is your if and only if. This one gives you freedom how to write it. So no, you have freedom there. Let's see if I can have, I just want to highlight that for you so you know which ones to use. All right. So a few things we need to know. Not all true conditional statements have true converses and vice versa, right? All definitions can be written as biconditionals. This is huge. In fact, I asked you to do that using our definitions from the last unit. Did everyone get a hint what's on your quiz on Wednesday? I just said any definition can be written as a biconditional. For example, collinear points. Points are collinear if and only if they lie on the same line. Right? Yes.
That means biconditional is just a different way of writing.
And but again, you want it to make sure it works either direction you choose. So the main thing is biconditionals allows you to say, hey, it goes both directions and it's always going to be there for me. I'm not going to have to second guess it. So that's why it's really nice for like definitions like congruent angles. Angles are congruent if and only if they have the same degree measure, right? So understand, don't forget last unit stuff because we're still going to be using that. So hint, hint for your quiz on Wednesday. Review first semester's notes definitions so you can write a biconditional for me. Heads up on that? Good? All right. Now, also you need to understand not all conditional statements are always written in if-then form. Life would be really boring if every conditional statement was written in if-then form. That's just poor writing, okay? But now I'm going to always ask you to keep it simple. Write it in if-then form so you don't mess up. But I do expect you to understand that they can be written in different forms. Look at all these little quirky little forms. What if I put the conclusion first and the hypothesis last, but I put an if in the middle? What if I go P implies Q? Well, if P, then Q should happen, right? That's what words implies. We have P only if Q. Only if actually takes the place of the word then. Does talk about confusion on that. And then we have all P are Q. It's a very overcoming statement. Let me give you some specific examples. Go to your last page there. Oh, look, I made it easy on you. Showed you how this one phrase can be written so many different ways. So here's what happens on the homework. On the homework, I'm going to have conditional statements written like any of these 5 that you see. You have to be good enough to figure out which is the hypothesis and conclusion using this notes to help you out. Are you guys with me on that? So let's just let our hypothesis here always be in yellow. I'm going to highlight it in yellow just so it makes sense. Now, the very first one makes sense to all of us. If a number is even, then it has a factor. Is that true? That's a true statement, right? So it's very much the if P, then Q. Notice the switch, and it's still a conditional statement. A number has a factor if it is even. So notice there's your hypothesis this time. It was written last, but it still, is it implying that it's the hypothesis? Yes. Then the next one, a number is even implies it has a factor. All of these are saying the exact same thing. So right now, all I'm doing is putting your hypothesis every single time in yellow. Now, how about this one? A number is even only if it has a factor. Notice how only if changes. The if throws us off. But only if really replaces what word? Then. So your hypothesis is still a number is even. Now this is the hardest probably one for most people to get. But it says here, all even numbers are numbers that have a factor. Isn't that say, if you have an even number, then automatically what do you guys know? It has a factor. So when you say this, it's all encompassing. This is still, believe it or not, your hypothesis. So again, on your homework, I'm going to give you like 5 sentences, and I want you to either underline or circle. I can't remember which one. Make sure on the worksheet you read it careful which one. You always know how to pick out the hypothesis. Now, they all mean that first sentence. They all have the exact same meaning and implications, but they can be written differently. Now, guys, on your worksheet, let's see if I have it saved up here so I can show it to you. I don't know if I did or not. Actually, I do. All right, good. I do have the worksheet here. This is a worksheet online that you have to do. Look at me now. I don't want it typed. How do I want it? I know, it's hard for me to read, but please don't type your homework. I want you to handwrite. But notice on the very first one, it just says, underline the hypothesis, circle the conclusion. What do you guys think? Look at number 6. It says, write a conditional with the given hypothesis and conclusion. You don't need to be fancy. Keep it as an if-then statement, please, okay? Tell me if it's true or false then. Then here's the part where it really messes people up grammatically, all right? Try to do like what we did in class. Make sure your pronouns go only into the conclusion. Are you guys with me on that? Also, you need to do this, guys. Don't leave till I talk to you on this, okay? It says here, for each conditional statement, write its converse, inverse, contrapositive, and Biconditional if possible. Biconditional doesn't happen every single time. But the other three do. So I would make sure if I was doing this homework, make sure that you write converse. Well, don't write it in highlighter though, because that's unreadable. But write converse. Write your if-then statement then. Write inverse. Write your contrapositive. And if it's true, and only if it's true, your biconditional. So this one is your iffy one. Are you guys with me on that? So the other three you should have no matter what, even if they're true or false. Got it? All right. Go to community time, my friends.
Thank you.